Hi everyone, this is the video for 6.5 since I'm not there today. So last time we talked about matrix arithmetic and now we're talking about inverses. We'll go over the homework next class for 6.4. We'll go over that homework next time. So the first part of talking about an inverse of a matrix is the determinant. So the determinant is a scalar value that can be computed from the elements of a square matrix. And the determinant is denoted by DET. So determinant A, determinant of A, or these vertical lines that look like the absolute value symbol, but that just means the determinant of matrix A. The determinant of a 1x1 matrix is just the number that's inside the matrix. And the determinant of a 2x2 matrix is A, D. Ooh, I don't like that. Let's see if we can fix this. AD minus BC. Make that a little smaller. So you probably learned this when you learned about matrices in like secondary math 2, but what you do oh my goodness, sorry guys. Okay. So, I think my Apple Pencil just died. That's probably what it was. Oh, no? Okay. So many errors. Here we go. Well, that works. Okay, we'll just go with it. So you do like this little fish symbol. So A times D minus B times C. I don't know if you've ever learned that, but that is what I teach my students. I want this to work, and I don't know why it's not working. Oh, it's because it's on the text. Okay. I see. See, there we go. Okay. AD times BC. So it's like this little loop-de-loop, little fish, whatever you want to call it. That's how you calculate the determinant of a 2x2 matrix. So we're going to do these practice ones. So on the first one, it's a 1x1 matrix, so the determinant is just 3. On the second one, this is where we do the fish thing. So that would be -3 times 8 minus 2 times 5. So -24 minus 10 gives you -34. And that's the determinant. So I'd like you to try that with 3 and 4. So pause the video, try those, come back. So on number 3, it would be 13 times 2 minus 4 times 8. That's 26 minus 32. So that's just -6. And then on number 4, when we do the little fish, that would be 5 times -10 minus 9 times 7. So that's -50 minus 63. That's -113. So the determinant equals that. Okay. So we need, on your paper, it goes into how to do a 3x3, but we're going to stick with the 2x2s for a minute. Then we'll go back and do the 3x3s. So the reason why we need a determinant is for the inverse of a 2x2 matrix. And 2 matrices are inverses if their product is the identity matrix. And if you remember from last time, the identity matrix is like ones on the diagonal, zeros everywhere else. So if you can take a matrix A times its inverse, which is A to the negative 1, and it's the identity, then those are inverses of each other. And a matrix that has an inverse is called invertible. We need the inverse to be able to solve problems. Which is what we're doing at the end, right here. We can use matrices to solve a system of equations. We can use the matrix inverse. So, where was I? Right here. So the way you find the inverse of a 2 by 2 matrix is 1 over the determinant of the matrix A, and then you switch A and D places, and you switch the sign of the other diagonals, the B and C. And that's right here. So we just talked about how to find the determinant. You need to have the determinant to find the inverse. So let's try it. Well, we'll check if these two matrices are inverses of each other first. So I'm going to take this top row and I'm going to write it along here. And this is a 2 by 2 times a 2 by 2. So we're going to get a 2 by 2 as our result. We have 15 minus 14. That's first row times first column goes here. And then we have first row times second column, that goes here. So that's negative 35 plus 35. So far, so good. That's 1, 0. And then we're going to take our second row and put it here. And that's 6 minus 6. And then negative 14 plus 15. So that's 0, 1. So are these matrices inverses of each other? Yes, because this is the identity matrix of size 2. Okay, so now we're finding the inverse of A. So that's 1 over the determinant of A, which is the fish thing. So that's 8 minus 6. So 1 over 2 for the determinant. The determinant is 2. And then we switch this 2 and 4 places, these ones. And then we make these ones negative. So negative 3, negative 2. And we're going to multiply that in. We're going to multiply this fraction in to each of those. So that would be 1, negative 3 halves, negative 1, and 2. And that's our inverse. Okay, so you have this page that has these 4 2 by 2 matrices. I'd like you to pause and try doing the inverse on these 4 and then come back and see if you did it right. So the determinant on the first one is 1, and then this would be negative 4 and 1 switch places, then negative 1 and 5. Those are the signs switched, so that with multiplying the determinant in, it's, or the 1 over the determinant, that's just 1. So Not too bad on that one. On the next one, with our little loop-de-loop, that's -4 times 7 minus 3 times -8. So the determinant there is -4. We switch these two places and we switch the sign on these. So that would be +8. So then this would be -7/4, +3/4, -2, and +1 for the determinant. Okay. This would be 20 minus 12, so the determinant is 8. So A inverse is 1/8 times -4, +3, +4, and -5. So this would be -1/2, 3/8, +1/2, and -5/8. And then on the fourth one, this would be 9 minus 8, so that's just 1. That's nice. So that would be -9 here, -1 here, and then +1, +8. And that's just the inverse because it's 1/1 in front. Okay, we're going to come back to this in a minute to do the other way of finding the inverse. But first we're going to talk about a 3x3 determinant. So this one is more complicated. There's 3 rows, 3 columns. And so it's just a little bit more complicated because it's a bigger matrix. And step 1 is to rewrite the first and second column to the right of the matrix. So we're going to take this one and we're going to write it here. So A, D, G. And then we're going to take this one and write it next to it. So that's B, E, H. Okay, and then we're going to multiply 3 numbers diagonally starting in the upper left corner. So that's A, E, I. And we're going to add that to B, F, G. We're going to add that to C, D, H. Okay, so you add those all together. And then we are subtracting these ones multiplied together. So BDI minus AFH minus CEG. So that is how you find the determinant. You calculate the determinant of a 3x3 matrix. Okay, let's try it. So, oops. Oh, gotta use 2 fingers. Okay, so we're gonna try it on this one. So I'm gonna take my first column and write it again, and then my second column. So we're multiplying these 3 numbers together. That would be 3 times -1 times 1 is -3. And then negative 2 times negative 2 times negative 2 is negative 8. And then 5 times 4 times negative 3 would be negative 60. I guess I could write it as plus negative 8 plus negative 60. I'm hoping that the color coordinating is helping. And then we're subtracting these three numbers multiplied together. So that's negative 8. And then negative 3 times negative 2 times 3 is 18. And then this would be 10 minus 10. I don't know why I'm putting parentheses here. Okay, altogether, that is negative 91. So that would be the determinant of this matrix. I think that's the only example that I have for finding the determinant. It's pretty easy once you know how to do it, I think. So you're just multiplying and you're adding these ones, and then you're subtracting these ones. So that's how you find the determinant of a 3x3 by hand. Graphing calculators that can do matrices can do this. So a TI Nspire can find the determinant, it can find the inverse, it can do all of that stuff, but you're not allowed to use a TI Nspire on the exams. And you really shouldn't use them in the class at all because, yeah, you're just not supposed to. So anyway, so we talked about how to find the determinant, but then we need to find the inverse. And finding the inverse of a 3x3 matrix is different than a 2x2. So what you do for a 3x3 matrix to find the inverse is you make it into an augmented matrix. So I'm going to take my original matrix here. I've got to zoom in, and I'm probably going to adjust this really quick. Okay, so 5, 1, negative 5, 1, negative 1, 0, negative 4, 3, 1. So we are going to augment that with the identity matrix of a 3x3. The 3x3 identity matrix. And the goal when you are doing the inverse of a 3x3 is that you're going to do row operations until this one becomes the identity matrix, and this will be your inverse. So that's the goal. So we are going to do row operations and get the left side to be ones on the diagonal and zeros everywhere else. So the first thing that I like to look for is if there's already a 1 in the first column. And there is one. That's a really big highlighter for how zoomed in I am. Okay, so this 1 right here would be nice if it was in the top row. So I'm going to switch row 1 and row 2. And you have to remember to do the entire row. So now, this would be 0, 1, 0 here. And then we're switching, this would be row 2, our new row 2, and then row 3 didn't change. Okay, next, this, if we add those together, that would be 0. That would be really nice. So my new row 2 is going to be row 2 plus row 3. I don't think I quite have enough room to write it over here, so I'm going to go down here. Well, I'll write this up here first. 5, 1, -4, 1, 0, 0, and then -5, 0, 1, 0, 0, 1. So that would be 0, 1, -3, 1, 0, 1. Sorry, that is so tiny over here. Okay, so our new row 2 is 0, 1, -3, 1, 0, 1. And row 3 didn't change. Okay, now I can zoom in on this a little bit more. Okay, so now the order, it's best to get a 1 here, then the 0 here, then the 0 here. It's just helpful so that you're not backtracking at all. So in order to get row 3 to have a 0 here, we could do 5 of row 1 plus row 3. And I'm going to write my math down here. So this would be 5, -5, 15, 0, 5, 0. And that would be -5, 0, 1, 0, 0, 1. So that would be 0, -5, 16, 0, 5, 1. And that's our new row 3. So now I can just copy, boop, boop, boop. I can just copy the other 2 rows that didn't change in this step. And this one did. So 0, -5, 16, 0, 5, 1. Okay, the next step in getting reduced row echelon form, or to getting this to be the identity matrix, is to have this be a 1, which it is. So now we move on to this one. We want that to be a 0. So luckily, this number right here, if we multiply the second row by anything, these 0 and then add them together, the zeros will just stay 0, which is the point of getting a 0 here first and then a 0 here, so that when you add this second and third rows together, this just stays zeros like we want it to. Okay, so to change row 3, we're going to do 5 row 2 plus row 3. So that's 0, 5, -15, 5, 0, 5, and then 0, -5, 16, 0, 5, 1. We're going to add those together. So 0, 0, 1, which is super nice that is how that worked out. And then that would be 5, 5, 6 on that side. Okay, so first row didn't change. Second row didn't change. And then the third row is 0, 0, 1, 5, 5, 6. So that bottom row is done, and we know that that is the bottom row. This is the bottom row values for our inverse. The next nice one to do is this one. We want to make that -3 a 0. So we're going to change row 2 and we're going to do 3 row 3 plus row 2. And so then that'll get these to add together to be 0. So that's 0, 0, 3, 15, 15, 18. And we're going to add that to 0, 1, -3, and 1, 0, 1. So our new row 2 is going to be 0, 1, 0, which is what we want. And then this will be 16, 15, 19. And again, I don't think I have quite enough space to write it on that side, so I'm going to rewrite it over here. And we're almost done. Just a few more steps. So first row didn't change. Second row is 0, 1, 0, 16, 15, 19. And the third row didn't change. So we're really close to having our inverse. The second row and third row are exactly where they need to be. We just need to get the first row to have a 0 here and a 0 here. So the nice thing is if we add these two rows together, that will get us our 0 in the middle column. So I'm going to change row 1 to be row 1 plus row 2. And I guess I don't really need to write that out. So that'll be 1, 0, 3. If we're just adding, that's 1, 0, 3 on that side. And then 16, 16, 19. And these take up so much paper, so much space, because it's just changing one thing at a time. 5, 5, 6. Okay, and then our very last step is that we need to change row 1 so that this is a 0. We can do that by doing row 3. So I'm going to say minus 3 row 3 plus row 1. You could say 3 row 3 minus row 1. It doesn't really matter because the signs will turn out to be the same. So this would be 0, 0, negative 3, negative 15, negative 15, negative 18, and we're adding that to our top row. So when we add those together, we get 1, 0, 0, which is what we wanted, and then we have 1, 1, 1 along the top. So this is now the identity matrix, which is what we wanted, and this is now the inverse. So we can say A inverse is 1, 1, 1, 16, 15, 19, and 5, 5, 6. So you might be wondering what the point is of having the inverse. So some questions on your homework might just ask you for the inverse, but there are questions like this where you're solving a system of linear equations and you need the inverse. Or you're given the inverse, because like this 4x4, that would be crazy because it's the same process for anything bigger than a 2x2 is you put your matrix on one side, identity matrix on the other, and then you do row operations until you get the identity matrix on this side. The reason why we do this, I have plenty of space right here. So we can rewrite a system of equations as AX equals B, where you have your A, you've got X, which is like XY or whatever the variables are, and then B is whatever's on the other side of the equal sign. And if this was like 3x equals 4, we would just divide by 3, right? But with matrices, it's different. So we have AX equals B. We don't have matrix division. That's not defined. So we can't just divide by A. So what we do instead is we use the inverse. So if we multiply both sides by the inverse, A inverse times A right here, we just learned that that simplifies to the identity matrix. And the identity matrix times any other matrix, it doesn't change anything. So that would just be X equals A inverse B. And order does matter. So this A inverse should be first because we're multiplying it first on this side. So it should be first on that side, or the furthest left, I guess. So once you have the inverse, you can multiply by the B matrix and you get your solutions. So A inverse B in this example would give us like, I didn't put any numbers in here, but if it was like 7 and -1, that's equal to X, which is XY. So then X is 7 and X is 7 and Y is -1. Right, so that's the point of finding an inverse, is that it's a different way to solve a system of equations. And you can do this method with 2x2s, the method where you augment it with the identity matrix. So you could do -5, -3, -4, -4, and augment it with the identity matrix and then do row operations to get it to be the identity matrix over here. And then this would be your inverse. And on this one, it doesn't take too many steps. So I'm just going to go through it. I'm going to do row 1. I'm going to do negative row 1 plus row 2. So that would be 5, 3, -1, 0, plus -4, -4, 0, 1. That gives you 1, -1, -1, 1. And then our second row didn't change. Okay, next I'm going to get this to be a 0. So I'm going to do 4 row 1 plus row 2. So that's 4, -4, -4, 4, plus -4, -4, 0, 1. So that's 0, -8, -4, and 5. I might run out of space. Oops. Oh, that's not what I wanted to have happen. Okay. Then we want this to be a 1. So I'm going to do row 2 is -1/8 of row 2. Just going to write a little smaller here. That would be 0 and 1. That was the point of what we're doing. And then 4/8, positive 4/8, which is 1/2. And then -5/8, which is good because look right here. Ta-da! We're getting there. So then we just have one more step to get the top row, which I'm just going to write down here. So then row 1 is going to be row 1 plus row 2 because we want this to be a 0. If we add row 1 and row 2, then that will be a 0. So we have 1, 0. This would be -1/2 if we add these two together. And then if we add these two together, that is 3/8. And then this would be 0, 1, 1/2, and -5/8. And that's exactly what we found doing the little fish method and then switching them places. So it's easier to find an inverse of a 2x2 matrix by hand by doing this method, but it can be done using row operations. Just takes a little bit more space, a little bit more time. And like I said, that's not an option for anything bigger than a 2x2. This is only available for 2x2s. Any 3x3 and bigger, you have to do it this way. So I'd like you to try doing this second example. Okay, so pause the video and take as much time as you need. You can follow step by step. And remember, with matrices and row operations, as long as you're doing something valid, there's not like one correct path to get to the inverse. You can do different steps than what I'm going to do. So just try to do it your own way and see if you can get to the identity matrix, and then come back and see if you got the same answer as I did. And if not, then, go watch through the steps of what I did and see if you can find where our steps differed or where you made a mistake. But yeah, so I'm just going to go through and do this. And I'm going to be a little bit lazy, and I'm just going to turn this into our augmented matrix without rewriting the whole thing. Save myself a little bit of space and a little bit of time. So I like that this is a 1, so I'm going to keep that there. Our next step, this is good. Our next step is to get this to be a 0. So I'm going to change row 2. I want to make that a 0. So I'm going to do -3 row 1 plus row 2. So that would be -3, -9, -3, -3, 0, 0. And I'm adding that to this row. This is 0, -6, -5, -3, 1, 0. So that's what is going to replace row 2. So again, I can just copy in row 1 and row 3 because those didn't change in this step. And row 2 is now 0, -6, -5, -3, 1, 0. Okay, our next step, the nice thing to do is get this to be a 0. So I'm going to change row 3, and I'm just going to say row 1 minus row 3. And I'm not going to write out each individual, I'm not going to write out the math like I did here because it's just subtracting. But row 1 and row 2 aren't changing, so I can copy those in. And then 1 minus 1 is 0. Oops, which is what we want. 3 minus -4 is 7. 1 minus -5 is +6. And then we have 1, 0, 1. 1, 0, -1, sorry. 0 minus. It would be 0 minus 1, so that's -1. Okay. Do I think I could make it? I don't know. We'll try. We'll try to make it all in this one row. Okay, so now the next thing that's nice is to get this to be a 1. And instead of dividing by -6 and having all of these fractions, it actually works out well to just add row 2 to row 3 because -6 plus 7 is 1. So that way we keep whole numbers. If you want to divide by -6, that's fine. I personally would avoid fractions if I had the choice. whenever I'm doing this, because fractions make it just, it's less easy to do those calculations in your head, I guess, is what I'm thinking. But anyway, so we're going to add those together. That would be 0, 1, 1. And then that's -2, 1, -1. And that's just adding these together. Boop, boop, boop. But I'm not going to leave that on my notes. Okay. So next, let's go over here. Go down a little bit. So now what we want to do, we have 1, 0, 0. We have 1. We want this to be a 0. So this is already a 1. So if we do -7, if we make this -7 plus 7, that would be nice to add together. So for row 3, I'm going to do 7, -7, row 2 plus row 3. And I am going to write out the little calculation down here. So 0, -7, -7. And then -14, or I guess it would be +14. 14, -7, 7. Okay, and then we have 0, 7, 6, 1, 0, 1. So that's 0, 0, -1. It's nice that it's just a -1 because that's going to be our next step, is to get that to be +1. So that's 15, -7. Did I write that down right? Oh, this is -1. Oops. I'm glad that I caught that. One little mistake and then the whole rest of your problem is wrong. Okay, so this is our row 3. 0, 0, -1. 15, -7, 6. And rows 1 and 2 have not changed. So can I get this all on the screen? Okay. 1, 3, 1, 1, 0, 0, and 0, 1, 1, -2, 1, -1. Okay. We're doing it. Okay, like I said, 1, 0, 0, then 1, 0. Next, we want that to be 1, just +1. So we're going to do row 3 times is just switching the sign. So I guess what we could have done is we could have said +7 minus row 3. That would make it so that it was just one step, but I didn't do that, and I'm not going to go back and rewrite everything. So here we go. 0, 1, 1, -2, 1, -1, and then 0, 0, +1, which is so nice. And then -15, +7, -6. Okay, next we did this, 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 right? All of those are done. So now the next easiest one is to get that to be a 0. So in row 2, I'm going to do row 2 minus row 3. Top row does not change. Bottom row does not change. And the bottom row shouldn't change anymore because it's in the right form. So if we do row 2 minus row 3, that would be 0, 1, 0, which is what we want. And then -2 minus -15 is +13. 1 minus 7 is -6. Oops, I needed to erase that first. -6. And then -1 minus -6 is positive 5. Okay, we are so close. And I'm not going to have space to write the whole matrix here, but that's okay. So our next step is to get this to be a 0. So we're going to change row 1, and I'm going to do -3 row 2 plus row 1. So that would be 0. How much space do I have? 0, -3, 0. Goodness. Okay. -3 times 13 is -39. It just feels like a really big number for a matrix. -39, positive 18, -15, and we're going to add that to our 1, 3, 1, 1, 0, 0. So that would be 1, 0, 1, -38. That is a really big number for, it's fine. It's fine. -15. Okay. So now I have to go back and forth. 0, 0, 1, I know is along the bottom, and that's -15, 7, -6. And then I know this is 0, 1, 0, and that's where it's supposed to be. And that's 13, -6, 5. So now all I need to do is copy in the top row, which is 1, 0, 1, -38, 18, and -15. Okay, our very, very last step. We need to get this to be a 0. It's easy because we can do row 1 minus row 3. And that will just get us where we need to be. So row 1 is going to be row 1 minus row 3. I'm going to make my life a little easier and just write these in. Oops, sorry, that should be -15, 7, and -6. And this is going to be 1, 0, 0. Yay, that's what we wanted. So now all we need to do is figure out what the top row is. So -38 minus -15 is -23. Ooh, okay, I guess that circle's staying there. -23. This one, I don't like that I can't erase that. Can I? I don't know. Nope, it's fine. 18 minus 7 is 11. And 15 minus -6. 15 minus -6. It's 23, right? Did I miss something? It's different than the key that I have. I must have made a mistake on that. Because I think that that's right. Right? 15 minus -6. Did I copy something over wrong? Oh, I did. Okay. Whoop. Glad that I found my mistake. This is supposed to be -15. So -15 minus -15 minus -6 is like -15 plus 6, which is -9. Okay. Whew. We did it. Okay. So this is the inverse. This is your identity matrix. So now what do you do once you have the inverse? Once you have the inverse, you can solve the system of equations. So I'm going to put this in matrix form, which just means we're putting the coefficients on the x's in the first column of our matrix, and then the coefficients on the y as the second column. The variables that we're using are x and y, and this is equal to -6, 0, like this. So we want A inverse times B. So A inverse, we're going to do the little loop-de-loop. That would be 9 minus 3, which is 6. Oops, sorry, that's the determinant. So the determinant of A is 9 minus 3, which is 6. So this is 1 over 6. And we're going to switch these places, but they're the same. And then we're going to switch these signs. So our inverse is negative 1/2, negative 1/2, negative 1/6, and negative 1/2. Now we're going to do, I guess I'll write it over here, A inverse times B. So that's negative 1/2, negative 1/2, negative 1/6, and negative 1/2 times B, which is negative 6, 0. And we're taking our top row. We just reviewed how to multiply matrices. So we're going to take our top row. And that is 3 plus 0. And then our bottom row, negative 1/6 times, negative 1/6 and negative 1/2. So that's 1 plus 0. So the solution is 3, 1. And remember, that's x equals, right? This is x equals. And so that's x, y equals 3, 1. Yay, so x is 3, y is 1. So that's the point of using the inverse to solve the system of equations. Okay, the other type of problem that you could see is this one. So it has 4 variables and 4 equations, and they were very nice to give you the inverse. So this is A inverse. This is our B matrix. So we're going to do A inverse times B, and then that will give you X, Y, Z, W. So A inverse is 3/10, 9/10. You know what? I'm going to be lazy and write B. I'm going to say that this is B, even though that was the place we were supposed to write our answers. But then I'm going to say that this is our solution, and that'll just make it so I don't have to rewrite this big matrix again. So we're taking our top row times the column. To make it easier, I'm going to do 3/10, 9/10, 1/5, and negative 2/5. So in that top, this is going to be our top row only column, right? It's the only column that we have. So this would be 9/10 plus 9/10 plus 0 minus 8/5. And I will simplify that in a minute. Now we do the second row. So this is 2/5, negative 4/5, 1/10, and 3/10. So do you remember how to multiply fractions? You just multiply the numerator of this one times this number, and the denominator stays the same. So this would be 6/5 minus 4/5 plus 0 plus 12/10. Like I said, I'm going to simplify all of this in a minute because I'm just going to get it all written down. So 1/10, 3/10, negative 1/10, negative 3/10. So 3/10 plus 3/10 plus 0, because that third row is 0, and then, oops, minus 12/10. Okay. 1/5, -2/5, -1/5, 2/5. Okay. 3/5 minus 2/5 plus 0 plus 8/5. Okay, so now I'm going to use my calculator to simplify all of those fractions. Okay, so the first one simplifies to 1/5. And then we have 6/5. I guess I don't need to say this out loud. The next one simplifies to 8/5. That's -3/5. And this is 9/5. And I believe I typed that all in right, but if I made a mistake, just let me know. So the solution matrix is what we just found. So X, really? My Apple Pencil died right on the last problem. But luckily they charge pretty fast. Okay, 1/5, 8/5, -3/5, and 9/5. And those are the solutions to the system. So that is the point of having an inverse. It's very nice. So far we've talked about using row operations to solve a matrix, or sorry, to solve a system of equations. Pardon my fast scrolling. Going back up to this one, if we take a system of equations and we put it into an augmented matrix and we get it into upper triangular form or row echelon form or reduced row echelon form, then that is one way to solve the system. What we just did, using an inverse, that's another way to solve a system of equations. Where are we at? Right here. With using the inverse. And then next class, man, so much scrolling, I apologize. We're going to be talking about a third option, which is called Cramer's rule. But your homework for tonight is fairly simple. You are using the inverse that they gave you to solve the system of equations. So that's exactly what we just did on this last problem. But on your homework, it's a 3x3. So there you go. Thank you for being patient and understanding why I'm not there today. My kids are sick, so I'm home with them. And I will see you Wednesday.